Can you hear? Can you hear? Yep, that's enough. Okay, I'm going to start now.
Sound is coming.
Yeah. Okay. I solved these problems in the class. I will only explain if you have any questions. For example, this one. Okay. Where are... Okay. Do you have any questions in this problem? Are you seeing this solution? I'm not just going to randomly what you are going to ask, but I have my own scheme. Are there any questions in the problem that I displayed on the screen? Okay, then this problem also I showed the solution in the class. Any problem here? I will pull out the solution sheet. Pardon? Okay. Just wait, I'm having some technical difficulties here. Don't know. I got some problem. Just wait. Things are getting bad. Okay, guys, I have problem with my computer. Just I'm sorting it out. Okay, now can you hear me? So a few S's. Okay, keep quiet like that, and please do not type unnecessary stuff here.
PDF file. So we upload the PDF.
All right. Um, these solutions to problems A5 and A5A and B, I gave them in the class. If you have any questions, you can ask me. Otherwise, I'm proceeding with the one problem that I gave you in the impact classwork. Look at this problem. Many students asked me how to solve this problem. I'm going to solve this step by step, and I want you to follow this carefully. Are you clearly hearing me? And can you see the problem? Okay, now keep quiet. Two smooth disks A and B have the initial velocities shown just before they collide at O. If they have masses MA equal to 8 kilograms and MB equal to 6 kilograms, determine their speeds just after impact. The coefficient of restitution is E equal to 0.5. Now this collision is oblique collision. This is a very general case. If you know how to solve this problem, you can solve any problems in general collisions. When oblique collisions like this, what I mean by oblique collision is both particles A and B, they are just moving in different directions. In this case, the velocities are parallel to the x-axis as it is given, but it may not require to be like that. They can be moving in any directions. And the collision is actually taking place on this axis. When the finally come and collide, that is the line of centers where the lines are joined. So when they are meeting at that instant in time, this is the line joining the centers. We call this as the line of collision. How do we treat this problem is take an axis along the line of collision and a perpendicular axis perpendicular to the line of collision, and say this is the line of collision or line of centers. I'm calling this as x dash. And so positive x dash is that way. And the perpendicular axis will be like this. And that is the positive, let's call it as y dash. We have to turn all the velocity vectors parallel to x dash and y dash and express them as components. The initial velocity components along x dash and y dash, and the final components of velocities along x dash and y dash. So we will find out what are the final velocities after the collision. During the collision, the velocity components along x and y we need to resolve this vector, which is the initial velocity of A, as a vector component along x dash and as a vector component along y dash. And because this is VA1, we call this as VA1 x dash. That is the component of initial velocity of A, which is VA1 along the x dash axis. And this one is VA1 y dash, component of VA1 parallel to y dash axis. Similarly, we will call this as VB1, and we will resolve this into a component parallel to x-axis, which is VB1x, and a component parallel to y-axis, which is VB1 y dash. Now the angles, we need to find these components. For example, this angle, if you call that as theta, this is nothing but this angle, in that theta equal to tan inverse 12 over 5, which gives you theta is 67.38 degrees. I suggest you follow every step carefully. Got the angle, so I can resolve this VA1 into components along x and x dash and y dash. So VA1 x dash is equal to VA1 cos theta, which is 7 cos 67.38. But because it is acting this way, it is towards the negative x dash, so I will put that as negative. Therefore, VA1 x dash is equal to minus 2.6923 meter per second. Similarly, VA1 y dash will be, it is acting towards the positive y dash, so plus 7 times cos 60, sorry, sine 67.38. Therefore, VA1 y dash is equal to 6.4615 meter per second. It's positive. These are the initial x dash y dash components of the sphere A. These are the initial components of velocities for that. Similarly, we get initial components of velocities for B, which is VB1 x dash. So what is this angle? If this is theta, this is theta, because the VA1, VB1 are parallel, and x dash axis is at theta angle with VA1. So it will be a theta angle with VB1 too. So this is equal to VB1 3 cos 67.38. So which is equal to 1.1539 meter per second. And similarly, VB1 y dash, which is this component, will be sine of that angle, but that is towards the negative y. We take it as negative minus three times sine 67.38, which is minus 2.7692 meter per second. I have VF1 and VB1 parallel to x-axis given, but I resolve them components along x dash and y dash using the known angle. This is what I have done. Is this clear so far? Any question I will answer in the chat session. Type it in. So everybody seems to be fine up to this point? Yes? Okay. Yep, I'll proceed with this. The next step is, along the x dash direction, the collision is taking place. We will have to apply two equations. One is principle of conservation of moment along x dash, total momentum before collision equal to total momentum after collision. And that will give you one equation where VB2x dash, VA2x dash will be two unknown quantities. We need one more equation. The coefficient of restitution equation also will apply in that equation, in that direction. We will apply that, get another equation, and solve those two equations. We will get VB2x dash and VA2x dash, which are the x components of the final velocities after collision of spheres A and B, which will make us to reach the half point of the solution. I will let you know what to do next, but first let's complete this part. What I'm doing, along the x dash, coefficient of restitution equation and principle of conservation of momentum is applied along x-axis, along x dash. Total momentum before equal to total momentum after. In all these cases, I write the equation first carefully using the notation that is used in the problem and substitute the known quantities and simplify the equation. So what we have now is mass of A times VA2 x dash, sorry, VA1 x dash, which is the initial momentum, 1 x dash, plus mass of B times velocity of B1 x dash is mass of A, velocity of A to x dash, the final velocity, plus mass of B, the velocity of B to, which is final, x dash. Substitute the known quantities. Mass of A 6 times velocity of A 1 x dash is where am I? VA1 x dash is minus. If it is a minus, you should substitute minus. If it is a plus, you substitute plus. By the way, mass of A is 8. 8 times this is negative 2.6923 plus mass of B is 6 and VB1 x dash is 1.1539. This is equal to mass of A 8, VA2 x dash plus 6 VB2 x dash. We can simplify this and write it as therefore 8 VA2 x dash plus 6 VB2 x dash is equal to minus 14.615. Divide throughout by 8 and simplify this. Therefore, VA2 x dash plus 0.75 VB2 x dash is equal to minus 1.8269. That is one equation. We have two unknown quantities. Now I'm applying along the line of collision or line of centers. Coefficient of restitution equation applies. What it is E equal to VB2 x dash minus VA2 x dash divided by VA1 x dash minus VB1 x dash. Substitute known quantities is equal to, we don't know VB2 x dash, we don't know VA2 x dash divided by VA1 x dash is negative 2.6923. If it is negative, substitute negative minus 2.6923 minus VB1 x dash. VB1 x dash is positive, this one. Substitute that. Minus 1.1539. Cross multiply and simplify. This will become minus VA2 x dash plus VB2 x dash is equal to minus 1.9231. That is equation 2. Now we can solve equations 1 and 2. We can get VA2 x dash is equal to minus 0.21975 meter per second, and VB2 x dash is equal to minus 2.1429 meter per second. Okay, we reached a major milestone. Most of the problem is solved. Any question up to this point? Will there be a case where momentum is not conserved? What do you mean? In along the line of center, momentum will be conserved. In sudden impact situations, momentum is always conserved, but energy is the one which is not conserved. What do you mean in the exam, Mr. Liam? If a problem involving collision of bodies is given along the line of center, the momentum is always conserved. Momentum is conserved in the y-dash axis individually, not together, because they are not actually colliding along the y-dash. I'm coming to that next. This part is clear. Along the x-dash, momentum is conserved and coefficient of restitution equation applies. These two equations allowed you to calculate two unknown quantities, that is VB2x dash and VA2x dash, the x components of the final velocities of the two spheres. Now we need to get the y components of the two velocities after collision, which are VA2 y dash and VA1 y dash. So the argument here is, let me put a separation here. Take some extra space. Draw along y dash. Momentum of each particle is individually conserved. Why individually? Along y-axis, they just brush past like that, tangentially move. There is no interaction. They just move. So momentum of A before impact is equal to momentum of A after impact along y. That is one equation. Second equation is momentum of B along y dash is equal to momentum of B along y dash after impact. So the plural for momentum is momenta. So what does it mean? Therefore, MA VA1 y dash, that is the momentum of A before the collision. This must be equal to mass of A times VA2 y dash, that is the momentum of A after the collision. But because MA and MA are the same, what it means is, therefore, the velocity of A along y after collision is equal to velocity of A along y before collision. Therefore, VA2 y dash is equal to the same as VA1 y dash, which is 6.4615. It just goes with the same velocity, 6.4615 meter per second. Also, AMB VB1 y dash is equal to MB VB2 y dash. Again, VB2 y dash equal to VB1 y dash is equal to, we know it is minus 2.7692 meter per second. Now we have the x dash and y dash components of velocity of A after collision. We need to add the two to get the total velocity, which is VA2 is equal to under root VA2 x dash square plus VA2 y dash square. So VA2 x dash is 0.21 5 square plus 6.4615 square, which gives us VA2, the total velocity of sphere A after collision is equal to 6.4652 meter per second. In a similar way, we can calculate VB2 as under root VB2 x dash square plus VB2 y dash square. Skipping that numbers, I'll put the final answer 3.5014 meter per second. So this is these are the two answers he's asking you. What are the final velocities of spheres A and B? This question is what maybe 6 to 11, depends on. Now tell me, what is your problem in this? Some students definitely ask me, okay, they are here while 2/3 of the class is not here. Okay, Caroline Portiers, did you understand the solution? Do you have any question? If you type that question here. If you understood, you say I'm fine. Worry about the real x and y axis now, because he is only the magnitude of the final velocity. Okay, now all of you, if you sit on this problem on your own, without looking at the solution I gave, can you solve it? If you cannot solve, you need to practice and finish. Yep, I've done my part. And if you don't have any questions in this, I'm going to move on with the 2015 exam questions. I will only upload this part online, but I'm not going to the 2015. Are you ready to go 2015? Okay, carefully follow. Now I will only discuss G and give the final answers and answer any questions that you may have. Okay, please stop using these faces and all those unwanted things. I want seriousness in this. Okay. A particle in rectilinear motion has acceleration varying with displacement as a function. So A is given as a function of displacement, where s is in meters. The initial velocity when s equal to 0 is v0 equal to 10 meters per second. The velocity when s equal to 20 meters is what? So when acceleration is given as a function of displacement, we use AdS is equal to v dv. So therefore, integral v dv, v0 is given as 10 meter per second. So 10 to v is equal to integral A is 5 minus 0.1 s ds. Displacement varies from 0 to s. Expand and substitute s equal to 20 meters, you get the corresponding velocity. And that velocity, the answer for this one is, where is the key answer? You should get 16 point something. The answer is B. All right, any question? Okay, two masses, MA equal to 40 kilograms and MB equal to 30 kilograms, connected as shown in figure A1B, are released from rest. If the coefficient of kinetic friction on the inclined surface is mu k equal to 0.15, the common acceleration of the system is, what you need to do in this case is, you need to take the free body diagram of A and free body diagram of B and apply the equation of motion for each of them individually. Then you will get like this. Friction, normal reaction, W, Wy, Wx, and the tension. And the whole thing is moving down with a constant acceleration. If you call that acceleration as A, so mass of A times the constant acceleration. The acceleration of both bodies will be the same because they are connected. And the free body diagram of MB will be the same tension T and mass of B times G, that is the weight of B, WB, and the whole thing is moving down with mass of B times acceleration. Apply equation of motion in these two cases. You will get two equations, two unknowns, the tension and the common acceleration. Solve the two equations, find what is the common acceleration. You will get 5.33 meter per second square. A is the answer. Any question? The x, y, and z coordinates of the points of the path of a particle in curvilinear motion are governed by the following equations. So here he gave you the displacement as a function of time, but each coordinate is individually moving. We can add all of that into a vector. 0.25 t cubed I plus 1.5 t squared j plus 6 minus 0.75 t to the power 5 over 2 k. He's asking what is the acceleration of the particle at a time equal to 1 second. First, find velocity as ds over dt. Just differentiate these t parts and write the vector. And then acceleration is dv over dt. Again, differentiate these t part of each. You will get another vector. That is the acceleration vector. In that, wherever t is, substitute t equal to 1 second. Then you will get the magnitude, the acceleration as a vector, something times I plus something times y plus something times I, something times j, and something times k. The magnitude is under root x component square plus z component square. When you do that, you will get the acceleration as 4.3772, which is B. Any question? The acceleration versus distance moved AS diagram of a particle in a rectilinear motion is given in figure A1D. When s equal to 200 meters, the velocity v equal to 20 meter per second. What is the velocity when s equal to 250 meter? What you need to do, as I told in the class already, at 250, you draw a line. This is acceleration, call this as A. This is displacement, call this as S. So A minus 2 divided by S minus 200 is the slope, which is minus 2 over 100. Simplify this and write a as a function of s. Once you have a as a function of s, as in the case of the previous problem, ads equal to v dv, integrate both sides, use appropriate limits, and find out what is the velocity substituting s equal to 250 meters. You will get 23.4521 meter per second, which is C. Any question? Any question? So we solved a number of problems like this. As you can see, these are scoring areas. Okay. In the rope and pulley system shown in figure A1E, block A moves down with a velocity of 8 meter per second. So VA equal to 8 meter per second there. The relative velocity of B with respect to A is what? First, let's find out what is the velocity of B. To find out, we just need to connect the connected motion between A and B. For that, how many ropes? As you can see here, let me erase this. This is one rope. And then this is the other rope. You call this as 2, this as rope 1. This is SD. This is, we can, SC. And this is SA. Rope 1 is SD plus SD minus SC, this part. And the next one is SA minus SC, this part. So SD plus SD minus SC plus SA minus SC equal to length of 1. Simplifying, 2SD plus SA minus 2SC equal to L1. Differentiating, 2 velocity of D plus velocity of A minus 2 velocity of C equal to 0. Then rope 2. It's simple. SD plus SC equal to L2. Therefore, VD plus VC equal to 0. Therefore, VC is equal to minus VD. Substitute this in this equation, we will get 2VD plus VA minus 2 times minus VD, which is plus 2VD equal to 0. Therefore, 4 velocity of D equal to velocity of A. Velocity of A is downwards 8. Therefore, velocity of D is equal to minus 1/4 times A, which is 8, which is minus 2 meter per second. We know particle moving away from the datum, we take it as positive. So VA is positive. We got negative. That means VD is moving up. So the relative velocity, therefore, VD is 2 meter per second upwards. So if a particle is moving 2 meter per second upwards and the other one, A, is moving 8 meter per second downwards, so the velocity of B, rather, it is actually velocity of, B is nothing but D. So the velocity of D with respect to A will be 8 plus 2, 10 meter per second upwards. Therefore, velocity of D with reference to A equal to 10 meter per second upwards. So our answer is this one, D. Any question for me up to this point? If you have any question or anything you didn't understand, please type it now. Can you repeat the positive and negative part? See, the datum is here. We take movement away from the datum as positive. So we are taking VA as positive 8. But VD is minus 1/4 VA. When you substitute VA is 8, VD is coming negative 2 meter per second. What it means is VD is moving up. So A is moving down, D is moving up. If you are sitting on A and looking at D, D appears to be moving up with your velocity plus its velocity, which is 8 plus 2, 10 meter per second going up. All right, what did you do at the end to get VDA? It is relative velocity. Yeah, normally relative velocities, if we use a vector, for example, VD is a vector, say VA is a vector, and VD is another vector. Velocity of D with respect to A will be that vector. This is velocity of D with respect to A. Velocity of D with respect to A is equal to VD minus VA, right? If you write it as vectors, it will automatically take care of the directions. But when we are moving like this, one guy is going down with 8 meter per second, and the other guy is moving up with 2 meter per second. When you sit here and look at that guy, he will appear to be moving up with a 10 meter per second. Rope 1 as 2 ropes? No, it is 1 rope. Okay, where am I? Where am I in this one? Yeah. Any other question? From the figure, is SD equal to SA? Now, they appear to be the same, but the moment they start moving, they will be at different levels. So you should not say they are the same. No. Shouldn't be VBA. But B is connected to D. Instead of calling it as B, I'm calling it as D for solving. If D is moving, because B is just connected to it, B also moves with the same velocity. Any other question? Okay, can I go to the next one if we have no problems? Okay, I solved these problems a number of times. There is particle B and particle A. There's only one curve. The equation of the curve is given. Y equal to 0.5 x squared. You differentiate this once, the second time, and use the equation for calculating the radius of curvature at point A and at point B. So you will get answers rho A as equal to 1 meter and rho B as equal to 11.1803 meters. You know how to do it. Similarly, use tan inverse y dash at the appropriate positions. Theta A, you will get 90 degrees, and theta B, 90 degrees or 0 degrees, because it will be parallel to the x-axis. Yeah, 0 degrees. The tangent will be parallel to the x-axis at A, and theta B, you will get it as 63.4349 degrees. Then you calculate the normal components of acceleration at B and A, and vectorially add, resolve them into x and y components, and write vector acceleration for B. Acceleration B vector will come to minus 4.2256i plus 4.3489j. And acceleration of A will be simple, minus 3i plus 25j. Once you get there, the relative acceleration of B with respect to A is equal to acceleration B minus acceleration A. When you do that, you will find ABA as equal to minus 1.2256i minus 20.6511j, and the magnitude of that as equal to 20.6874 meter per second square. That's it. If you have any questions, I will answer. Otherwise, we'll proceed. You need to solve this problem. Isn't the radius at A equal to 0? No. Why? The radius is at A, that is the radius. There will be a radius, but the tangent is horizontal. And so you will get theta equal to 0. All right. Yes. I'll ask you one question. So far, you have looked at equations like this: y equal to a function of x. For example, if someone gives you, instead of y equal to 0.5 x squared, say if it is x equal to 0.5 y squared, how would you apply these equations? You just follow the same procedure. Find x dash is 0.5 times 2y, and x double dash is 0.5 times 2, and use the same equation to find the radius of curvature. And then theta with the calculation of theta. For example, if a curve is like this, and if it is y equal to some x squared, then y dash is equal to 2x, then to tan inverse y dash. What is y dash? Dy over dx. So that theta is this angle, because this is dy, increment along y, and this is dx. In this case, tan theta equal to tan inverse x dash. But what is x dash? Dx over dy. So if the curve is like this, in this case, what you're getting is dx over dy. So if that is the line, dx over y, this is dx, this is dy, the angle you get will be this angle. Here the angle you get is this angle. Opposite divided by adjacent is tan. So dy over dx is this angle. Dx over dy is this angle. So in this form, we get the other angle. Is that clear? Or if you can easily differentiate it, write this as y equal to x. So in this case, what will happen? Y squared is 1 over 0.5x. Therefore, y equal to root 1 over 0.5x. So root x is going to come. If you are comfortable with that, rewrite and do it. Otherwise, follow the same method. Just be cautious with the angle. Any question? Can I move on? Can we say tan inverse 1 over x dash? No, sir. Yes, that is all this normal. Any other question? Okay, we are running out of time. Let me I solved this problem somewhere in the class. In all these problems, you need to write the expression for the total length of the rope. So the length of the rope here is, see, this part of the length is xa squared plus 4 squared under root, plus this is the remaining part. So the total length of the rope is root xa squared plus 4 squared is this part, plus this extra xc, plus xc is equal to the total length of the rope is given as 8. Once this is given, write it as xa squared plus 4 squared whole to the power half plus xc is equal to 8. Differentiate both sides with respect to time. So that differentiation is half xa squared plus 4 squared to the power half minus 1, which is minus half, but times 2xa times dx over dt, which is xa dot, plus dxc over dt is xc dot equal to 0. From this, xc dot is equal to xa minus xa, 2 and 2 are cancelled, xa dot divided by root xa squared plus 4 squared. But xc dot is velocity of c equal to minus x coordinate of a. Xa dot is velocity of a divided by root xa squared plus 4 squared. He gave you velocity of a 4 meter per second. S is 2.5 meters. So xc is 1.5 meter. Therefore, xa is equal to root 6.5 squared plus 4 squared, which gives you 7.632 meter. Substitute these quantities, you will get velocity as minus 7.632 times 4 divided by root 7.632 square plus 4 square, which is equal to 3.5428 meter per second. Any question? Any question? Harshita, how did you get 6.5 again, please? Okay, where is this 6.5? So he gave you S equal to 2.5. So this is a 2.5. XC is 4 minus 2.5. So 1.5. If XC is 1.5, the total length of the rope is 8. So this part is 8 minus 1.5, which is 6.5. So in a triangle, this is 4, this is 6.5. So XA is under root 6.5 square minus 4 square. This is minus, sorry. Yeah. Understood? From where I got it? From there I got it. These problems appear to be tricky, but they are actually easy if you know how to differentiate with respect to time. Write the length of the rope. That's it. This problem also, it is simply writing the length of the rope, but the only thing is he is asking you for acceleration. The equation has to be differentiated 2 times, and it will give you the final form of the solution. I'm just giving you the final answer here. Acceleration of V is equal to 3.3581 meter per second square, and the tension in the rope T is 1316.81 Newton. Right. You leave this problem. Let's focus on this one. A 2 kilogram block was originally pressed against a spring up to a point A, producing a maximum of X deflection in the spring as shown in figure A4. When released from rest at A, the spring expands, pushing the block to the right. When the spring attains its original length at B, that means it comes to zero deflection, all the energy stored in the spring will be gone into the block. The block leaves the spring and starts moving up like that. The frictionless curved path as shown in figure A4. Calculate the maximum compression in the spring X for the condition that the normal reaction from the track is 25 Newton when the block reaches the point C. So at point C, you should get a 25 what newtons. What is the compression in the spring needed? That's what we want. And also during the upward motion at D, what is its normal reaction? What you need to do in this case is second. Okay. You have the given equation y equal to 1 over 100 x squared. You need to find y dash, we need to find y double dash, and we need to find the radius of curvature at x equal to 30 meter and x equal to 50 meters. So which is rho d is equal to, you will get 79.30. You know how to do it. And the rho c is equal to 141.4214 meters. And theta c is 45 degrees. You know how to calculate. And theta d is 30.9638 degrees. So this is all straight away done. Then at C, free body diagram at C of the block. So you can two times 9.81. The normal reaction N acts like this, and we know the tangential direction makes 45 degree. We calculated it already. And this is our normal direction. You can write sigma Fn equal to mass times An. You know what to do with that. We will get what is the velocity with which it is moving to satisfy the given condition. You will get 28.0493 meter per second. So from the free body diagram, we got that velocity. For this velocity, with what compression you should release the spring, then what you need to do from A to C, you can apply the work energy equation, which is TA plus sum of the external works equal to TC. So 0 plus half times 2000 times x squared. That is the spring energy. It's work done by the spring. It is pushing the block. It's in the same direction. So it is positive work. And the gravity work is negative because it's going up. 9.81 times 25. How did I get this 25? Because at x equal to 50, what is y? You can use that equation. Yc is equal to 1 over 100 times x equal to 50 square. When you do that, you will get yc as 25 because at C it has that height, is equal to half times the kinetic energy, 2 times okay, what was the velocity? Yeah, 2 times 28.0493 square. Anything else? Yep, that is the final kinetic energy. So from this, we can calculate x, which is 1.1302 meters. This is the compression that you need. Okay, that K2000, I forgot to give in the problem during that year, and I was going around the exam halls announcing that, and so it was a mistake, typographical error. So it is given, you don't have to worry about it. And once you have that, A to D, you can apply TA plus sigma U A to D equal to TD. If you use appropriate quantities, you will get the velocity of D as 33.1779 meter per second. And after that, you need to take the free body diagram at D. mg, the weight, the normal reaction, and it is moving with a tangential velocity vd, and when you take the normal direction, sigma fn equal to mass times acceleration centripetal, which is v square over rho. Substitute those quantities, you will get n as equal to 44.5859 Newton. As you can see, I'm not giving the full solution, but I'm showing you the way. Any question? Mr. Bastian Bosch, that 2000 Newton per meter was not given by mistake, and it was announced in the exam halls by me in 2015, probably October or November. Any other question? Can we use conservation of energy instead of work? Yeah, why not? Because there is no friction here. You can use conservation of energy equation also. You will get the same result. The 25 is y equal to 1 over 100 x square. At x equal to 50, y is 1 over 100 50 square, which is 25. The y coordinate at D is 25, which is the height of it. Any other question? How do we know that the stiffness is? I told already, it was by mistake not given in the question paper. I corrected it in the exam halls later on. It will be given. Any other question? Is this session useful, or you're already knowing all these? Am I wasting my time and your time? Okay. Yeah, I think it is useful for many of you. That's good, because my time is very valuable. When I see only 84 students here, I got a feeling that I'm wasting my time. And probably you know all these things already. Okay, now let's spend, if it is useful even for one, I don't feel this as a waste of time. Okay, This is the standard the connected motion, equation of motion, and the elevator problem. So whether there are too many ropes or too many loops on a ropes, whatever, you don't have to worry about. The principles are the same. We solve 2 or 3 or 4 problems like this, and without losing heart, if you find a problem like this, apply the same principles. Okay, let's see what it is. The mass of the material hoist shown in figure A5A together with the load is 500 kilograms. The mass of the counterweight is 100 kilogram. The upward speed of the hoist increases from 1 meter per second to 2 meter per second in 2 seconds. That's a catchy information. We have 3 quantities specified: V0, final velocity, and time. We are getting attracted to use the standard kinematic equations, but can I apply or not? Now we need to check whether the forces are constant. If he is using a motor with a varying torque, then the force varies, but he didn't say anything about it. So we take it as constant. If the motor is pulling it with the same torque, then there is nothing that is changing. We can say the net force is constant and the acceleration is constant. We can happily use those equations and find out kinematics. V0, 1 meter per second. V equal to 2 meter per second. T equal to 2 seconds. V minus V0 is ACT. Substitute, we get, this is A elevator actually. AE. From this, acceleration of the elevator is equal to 0.5 meter per second square. We want the acceleration of C also, and for that, connected motion. In connected motion, there are 2 ropes. Rope 1 is SE. We will cut this here and call this as M. This is SM. So SE plus SE minus SM is L1. 2SE minus SM is L1. From this 2VE equal to VM, 2AE equal to AM. And the second rope is simple. We can just write SC, SE plus SC equal to L2. VE plus VC is 0. AE plus AC equal to 0. Now from, we already found A is 0.5. So AC equal to minus AE equal to minus 0.5 meter per second square. So we got AC. With that, you can go to the free body diagram of mass 2. Call this as tension T2. This as its mass is 100 times 9.81, and it is coming down with the 100 times acceleration of c. So we can use sigma Fy equal to mass times ac. From that you will get T2 931 Newton. Solve this at home. I got the tension T2. Go to the free body diagram of the elevator. Here you have two tension 1 ropes and one tension 2 rope, and the 500 times 9.81 is acting downwards, and it is going up with the me times acceleration e. So you can use sigma Fy is equal to mass of e times acceleration of e. This is equation of motion. After doing this, you will get tension 1 is 2112 Newton. That is the next answer we need. And what else we need? We already know the velocity of the elevator. But what is the velocity of m? Velocity of m is equal to 2 times velocity of e. Therefore, velocity of m equal to 2 times velocity of e equal to 2 times, what is the velocity of e? It starts with one velocity and goes up to 2 meter per second. So the velocity 0 is 0, 2 times 1 equal to 2 meter per second, and velocity final is 2 times velocity of e final, which is 2 times 2 equal to 4 meter per second. So Vm average velocity is 2 plus 4 over 2, which is 6 over 2, which is 3 meter per second. That means the motor is pulling the rope with an average velocity of 3 meter per second and under a tension of 2112 Newton. Therefore, the power output, average power output is equal to T1 times velocity of motor average, which is equal to 2112 times 3. So the average power output is 6336 watt. So the average power input is 6336 divided by efficiency 0.7, which is equal to 9051.4286 watt. So make sure you solve this problem and get all the answers correct. Any question? Why is T2 equal to 931? Where is T2? I applied this equation, T2 minus 100 times 9.81 equal to mass 100 times acceleration of c is 0.5 meter per second square. After substituting that and simplifying, I got to T2. But I took it in the direction of motion, so I don't need to use the negative. Together with AE, it is negative, but on its own, it's positive. How would we do this problem if force was not constant? If force is not constant, check if he gives any equation for the force. If force is given as a function of time, you can calculate the acceleration as a function of time and substitute the appropriate quantities. Okay, any other question? A5B I solved in the class. What is the question? Can you explain again how you took rope 1 length again? Rope 1, the length of rope 1 is, take that as the datum. This is SE, this is SC. So total length is, this part is constant, we can neglect it, that part. So SE plus SC equal to length. That's all. Any other question? Point 7. It is given in the problem. Efficiency is 0.7. Any other question? I solved this problem in the class. I just gave the same thing. Maybe I changed some numbers, but the procedure is exactly the same. The answer you will get is F is equal to 183, I believe, or 163. I think it is 183.0633 Newton. Maybe 163. Yeah, just check that. But it's exactly in the same lines as the problem given in the class. And this one, what's happening here is B to C, work energy equation. If you apply, you will get velocity of A with which it is going to hit C at the bottom. And then the impact where A is impacting against C. Here, mass of A times velocity of A plus mass of C times velocity of C equal to mass of A plus mass of C times the common velocity with which the two, because they are getting stuck together. If you use the appropriate quantities, the velocity will be 0.6975 meter per second. That's the common velocity of both A and C together. And then they are moving together under friction. So you take the free body diagram of further motion. So that is C, and then A got embedded into it. The total weight is 0.2 plus 2 times 9.81, the normal reaction N, and the frictional resistance F. This is how it is starting. That is 0.1. It moves and comes to rest, what is 0.2. So you can apply equation of motion and calculate in the y direction equation of motion and calculate N, which is 21.582 Newton. F is equal to mu times N. You will get F as 6.4746 Newton. And then use work energy equation. Then you will get the distance as equal to 0.08 0.27 meter. The work energy equation is 122 T1 plus sigma U122 equal to T2. What it will be is half mass 0.2 plus 2.0 times the initial velocity is the common velocity 6975 square. That's the kinetic energy. The work done is only done by the friction force, which is minus 6.4746 times the distance through which it is traveling. We don't know that, is equal to, it comes to rest at the end. After solving, we get S equal to 0.827 meter. Any question? That is A6A. Can you solve for A, then use kinematics? How? Why? You can, but why? This is easier. Any other question? This problem is I gave you in the test. I repeat sometimes problems, and this was repeated. And here, what is done? Mass of A is 0.5 kilograms. Mass of B is 1.0 kilograms. I will be uploading this solution anyway tomorrow morning before you come to collect your scripts. So I will quickly go through what it is. First, you need to analyze the impact. So from the impact, we use two equations. One is principle of conservation of momentum, mass of A, velocity of A at the start, plus mass of B, velocity of B at the start, equal to mass of A, velocity of A after collision, plus mass of B, velocity of B after collision. From this, you will get one equation. The second equation is velocity of B minus velocity of A is velocity of A at the start minus velocity of B at the start equal to coefficient of restitution, which is given as 0.8. Substituting the known quantities, developing the two equations, and solving for the two unknowns, we get VA as equal to 2.4 meter per second. It's going to the left. And VB is equal to 0.8 meter per second, also going to the left. You get negative values. After impact, and the two masses are individually moving, for sphere, energy conserved. What it means? T1 plus V1 equal to T2 plus V2. From that, we will be able to calculate H equal to 0.2936 meter. And for the block, because it's moving against friction, I think we'll use work energy equation. When I say I think, what's happening is I'm trying to wind up many things at the same time. My brain is not fully focused on this solution like the way I do when I come to the class. When I say I think, it doesn't mean I don't know, I'm confused. And so some students write feedback, this guy is confused, he doesn't know anything. It's not the case. I'm just trying to wind up a complex problem in a very quick succession in just a few minutes. That's the only thing, sirs. And substitute the known quantities. Here, what you get is T1 plus sigma U1 to 2 equal to T2. When you substitute all the quantities, you will get the distance it moves through as 0.05437 meters. I don't remember if I changed the numbers in this problem when I gave it in the midterm examination. It is 3 hours total exam, and 6 problems are designed to be solved in 2 hours. And there are people every year getting 100 out of 100 in dynamics, so which is clearly an exam for 2 hours. Yeah, I'm spending time explaining, but it's not explaining the problem solving. Okay, thank you, sirs, and enjoy and keep studying and solving these problems. And my part I did, and now it's in your hands. In the exam, apply the basic principles and solve the problem in the right direction. Whether you get the final solution or not, you don't have to worry too much, but attempting it in the right direction and using the equations appropriately and laying out the solution, if that is correct, you will pass. So that's what you need to do in the first place if you are worried about the final exam. The papers, you need to follow Shirley Leo because I don't deal with that part. You need to follow what Shirley said. I think it is 10:30 to some time and in some room. I'm not concerned with that. You need to go to Shirley, collect, and if you have any revaluation claims, you just submit there and then. And don't come to me. It will be handled and handed over to the administration from now onwards. All right. Any other question regarding this exam? I have already explained that. All right, I have to stop the session now, and all the best. Yeah, thank you.